Uh, Good morning. Today, our topic is using elementary row operation to find the inverse of a matrix. Now, in my previous lecture, already we explained that what is elementary operation and its classifications as per row operations as well as the column operations, and also I have also explained the three important steps of the elementary row operations. Today, basically using a 3 by 3 matrix, we would like to find its inverse using those three important properties that we have discussed already. That is interchange of rows for row operations, or for columns, interchange of columns, then product of the rows and additions of the rows for both, and number 3 is dividing or multiplying by a scalar product. These three important properties of elementary transformations that we can use over here. Now, whenever you are using row operations, you have to keep it in mind that suppose this is the equations A is equal to IA, and this A is equal to IA, I have replaced these equations in this way. For row operations, we always have to keep A to the right hand side, and this A will be kept constant and will be writing in this way, and I will not change this. Only here I will replace A instead of given matrix minus 1, 1, 2, 1, 2, 3 and 3, 1, 1. And here is the 3 by 3 identity matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. Now what I want to say that using this row operations, whenever you are doing this, our objective is very clear. The objective is that slowly and gradually, if in each steps we will try to change this matrix left hand side of A, and our destination is to convert this matrix A into an identity matrix. That is, I will change this matrix to these formations 1, 0, 0, 0, 1, 0, 0, 0, 1, and that is A over the 10 steps. That story I will tell you, that it turns into an identity matrix, and this identity matrix, whatever the operations I will use over here, the same operations also I have to apply in the right hand side for I matrix, and accordingly this I also will change. A as I say will be kept constant, and constantly I am writing this, and hence in the meantime this matrix will say transform into B, and I am saying that this B will be nothing but your inverse. This B matrix will be nothing but your inverse. So this is our target to reach. Now problem is that different books, they have done these operations different way. Students are also confused, and when in the examination hall, whenever they are applying this, they can't get the answer sometimes. Naturally, they are confused. So, if you follow this algorithm, later on also I will give you all the algorithm one by one using those three properties. If you follow this algorithm, you will be easily to reach the answer for A inverse. Now see, for this problem, inverse, I have in step 1, I have already written minus 1, 1, 2, then 1, 2, 3, then 3, 1, 1. So this A matrix has been written over here, and this is the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Definitely, since it is a 3 by 3 matrix, it is also supposed to be a 3 by 3 matrix. A should be written as constant. Now, in the step 2, just you see this instruction. This instruction is important. As I told you, that rows can be interchanged. So, here if you observe that R2 is in the R2, here it is already 1 is there. So, it is easily, if I interchange these two rows, this 1 easily can come over here. This is the challenge, that you have to always bring 1 along these principal diagonals. So easily I can, if I use this operation here, in such case I can get this 1 over here. Now tell me that every time may not that a 1 will be here. Here 1 luckily I got, so I interchange and I got this 1. In here, so to bring 1, if not no 1 is here, then what do? We have to then adjust, we have to apply the second properties, that is additions of rows or multiplying something. Suppose without doing this, I also could make it 1. How? If I suppose here if I multiply this by 2 and then if I write R1 is equal to 2 R2, I also could get 1. So that operation also we can do, but easier operation is that here I have easily done interchange of two rows. Another way also I can get 1 for this one only. But if I don't get any steps like this, I can divide this. Suppose 5 is here, or suppose -1 is here. I also could turn it 1 is -1, dividing both sides by dividing R1 is equal to R1 by -1. But that will be a complex. So what I have done, I have interchanged these rows. I also could do it dividing by -1. R1 is equal to R1 by -1 or minus R1. But here I have interchanged these same operations also I have done in over here. That is this 0, 1, 0 I have written over here and 1, 0, 0 I wrote over here. And the third rows 0, 0, 1 as it is I kept. Throughout this steps only I have used single operation for your understanding, so that you can't you can understand very easily. Now see the step 3. Step 3 is very interesting. Step 3 here, let's see, if I add, this is your R2. Now my target is to this part is 0. So how can, always remember why you are making 1. I have made this 1, so I have to use this 1. Please remember this. I have to use this 1 and to make this 2. This 2 1 is 0 0. This is your second row position, and this one is your second R3 positions. These 2 will be turned into 0 using this 1. And you remember not? So I have to make this 0 using this 1. No other alternative way. If you follow my algorithm, always remember I will use this 1 to make this other part is 0. My target is that first I made this 1, then I will turn this into 0, 0 and 0. Okay? So my next target is to make this first column 0, 0. How I made this 0? Just you see R2 is equal to R2 plus R1. If I add R2 plus R1, I will get 0. So simply I have added and I got 0. And 2 plus 1, 3, and 2, 3 plus 2, 5. Others R3 are kept unchanged. Same operations also I have done over here. See 0, 1, 0, it's unchanged. 1 plus 0 because R2 plus R1, 1 plus 0, 1, 0 plus 1, 1, and 0 plus 0, 0. And 0, 0, 1 unchanged. So I hope that you have understood step 3. Very easy to get this 0. Now my next target is to make this part 0. That is my first column. First I have made it 1. Then in the first column, this first column of second row, this has to be 0. That is, this is A21 position in matrix, and this is A31 positions. This part I have to make it 0. Now, how I got this 0? Just see, if I use R3 is equal to, this is R3. R3 is equal to R3 minus 3R1. Following the property, I can write this as R3 is equal to R3 minus 3R1. So if I multiply this by 3 and subtract from here, always remember whatever the position I am changing, that I have to write first. So R3 is equal to R3 minus 3R1. And same thing, minus 3 into 2, 6. So 1 minus 6 is equal to minus 5. And here it is 3 into 3, 9. So 1 minus 9 is equal to minus 8. So this R3 position has been changed. And similarly, here also the same operations I will do, and I will change these operations. Just see that this is 0, so there will be no effect. And here I got 0 minus 5. So this is minus 3 because minus 3 into 1 minus 3. This is 3R1. So minus 3, 0 minus 3 minus 3. And this is 1. So I got this is 0 minus 3, 1, and it is changed. So this first column had been changed into 1, 0, 0. This was my target. Whenever I did this, I saw next step is to make this 1. Always remember. First I will change 1, then the entire column I have to change. First I will change 1, change into 1, then entire column I change. In the first column also by row operations, I have changed the first, this is 1, and then entire column I have made it to 0. Similarly, using this 1. Similarly, my first target is to make it 1. Now see how I made it 1. Here it is 3. Sometimes you can see in the question, the way you are changing, automatically 1 can come. But here, unfortunately, 1 is not here. So I have to do some extra work. What I have done to make it to 1, I have done R2 is equal to R2 by 3. If I do R2 is equal to R2 by 3, entire row 0 by 3 is equal to 0, 3 by 3 is equal to 1, and 5 by 3. Always remember, once you have turned into 1, 0, 0, whatever the entire operations you will do, in entire operations, these 1, 0, 0 will not change. And again, I have changed it to 1, then in due course of other entire operations, I cannot change this 1 again. So, if you don't follow my algorithm, you will be in trouble. So, what I did, R2 is equal to R2 by 3. I could make this one, but once I do 2 minus 1, then this will be changed. So, I cannot do it. So many students are doing like that and they are in troubles. Just simply, either you see that automatically 1 will come over here, but here automatically 1 has not come, 3 is here. So, I have no other alternate way. I have divided this R2 is equal to R2 by 3. And whatever the operations I have done over here, same operations I also will do in right hand side also. So this is 0, 1, 5 by 3. The others rows are unchanged. And here it is 1 by 3. Here it is 1 by 3. And here it is 0 by 3, 0. Why 1 by 3? Because I have done R2 is equal to R2 by 3. 1 by 3 is equal to 1 by 3. 1 by 3 is equal to 1 by 3. 0 by 3 is equal to 0. And 0 minus 3, 1 as it is I did it. This is your step 5. And once I have done the step 5, you just see I have already transformed this into 1. Now using this one, now here it is step 6. What I have to do, using this 1, I have to make the other 2 columns. Second column has to be made 0. This is the target. First this is 1, then 0, 0. Then I have made this is 1 and then 0, 0. I can make either first 0 or 0 or that is sequence is not important, but using this 1 I have to make this part 0. So I have how I have made it 0? Series operation R1 is equal to, so this part this is 0, R1 is equal to R1 minus 2R2. Remember, since I am using this 1, because of this 0, this will not be unchanged. That is the logic what I told that you follow my algorithm. So once I did it, this will be 0 because minus 2R1, R1 is equal to R1 minus 2R1. This here actually, you just see in the step 5, I got, R1 minus 2R2, 0, 1. So if I multiply this by 2 and 2 minus 2, 0. So this is 2 minus 2, 0 and hence I got 1, 0 minus 2 by 3. This is 10 by 3 and 10 by 3 and if I subtract 3 minus 10 by 3, I will get minus 1 by 3. And the others will be remain unchanged. I will not touch it. Same operation again, the same story I will also do over here and that is 1 by 3, 1 by 3, 0 and naturally the same operation R1 is equal to R1 minus 2 R2. If I do, I will get, this will be changed into minus 2 by 3. Just see 0 minus 2 by 3 minus 2 by 3. 1 minus 2 by 3, 1 by 3. And this is 0. So this step 6, here I got this is part 0. The step 7, my next target is to make this column, last column of the second, last 0 of the second column I have to make, that is A32. How? If you see this instruction, R3 is equal to R3 plus 5 R2. R3 is equal to R3 plus 5. Tell with me. R3 is equal to R3 plus 5 R2. Why? Because if I made it to, this is your R3, I have to turn this 0 from here. If I multiply this by 5, 5 minus 5, 0. So this is has to be made 0. And others, this also unchanged, and this minus 8 will be changed into 1 by 3, because if I multiply this by 2 or 2 and then if I do it, it will come 1 by 3. You also can do rough operation in the right hand side. Here also, you just see that we have done same operations and I got this is this one minus 2